introducing complex numbers. And we are going to be answering the question, what are imaginary numbers? Question number 124 says, consider the equation x squared equals 2. When you solve x squared equals 2, how many solutions would you get? You would get 2 solutions because you would have plus the square root of 2 and negative the square root of 2. That's considered 2 solutions. We use that plus minus symbol. Okay? And part B says, how many x-intercepts does the graph of x squared minus 2 have? It's going to have 2 intercepts. It's a parabola. It's opening up. It's going to cross the x-axis twice. Okay? Part C says, solve the equation x squared equals 2. Write your solutions both in exact form and as a decimal approximations. So in exact form, we have plus or minus the square root of 2. If they want a decimal approximation, you simply type in your calculator the square root of 2, hit the equal sign, and you're going to get this big long decimal, 1 point, blah, 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 blah. So we're going to round it to 1.41. But we need to make sure we have the plus and minus. So you can either write plus or minus, or you can write 1.41, comma, negative 1.41. Just a preference thing, okay? All right. Question 125. Question 125 says, mathematicians throughout history have resisted the idea that some equations may not be solvable. Still, it makes sense that x squared plus 1 equals 0 cannot be solved because of the graph x squared plus 1 has no x-intercepts. What happens when you try to solve x squared plus 1 equals 0? So when we go to try and solve it, we would start by the inverse operation of adding 1 is to subtract 1 from both sides. You get x squared equals negative 1, and then you'd go to take the square root. Square root of x squared would just be x, but the square root of negative 1, you would say no real solution, because you can't have that negative under the radical. Okay? So for question 126, it says, in the 1500s, an Italian mathematician named Raphael Bombelli invented the imaginary number, which is now called I. Because I is defined to be negative 1, it follows that I squared equals negative 1. After this invention, it became possible to solve x squared plus 1 equals 0. The solutions are x equals I and x equals negative I. Because of this, we can also simplify the square root of negative 4 as the square root of 16 times negative 1, which is equal to the square root of 16 I squared, which is equal to 4i. Use the definition of I to rewrite each of the following expressions. Okay, here we go. No longer do we say no real solution. Now we can give answers with I in them. Okay, so we're going to have imaginary numbers in our answers. If it has a real part and an imaginary part, we call it complex. Okay? All right, so for part A, we have the square root of negative 4, which we are going to rewrite as the square root of negative 1 times the square root of 4. Hopefully, the square root of 4 you can do in your head. Square root of 4 is 2. we just learned that the definition of the square root of negative 1 is I. So the answer is 2I. Okay? That's an imaginary number. All right? Part B. Now we have 2I times 3I. The easy part is the 2 times the 3. The 2 times the 3 is 6. That part should be easy for you. Then we have I times I, which is I squared. That's kind of like if you have x times x, you get x squared. So if you have I times I, you have I squared. But one of the other definitions that we also just saw was that I squared is equal to negative 1. So we're going to take 6, and we're going to multiply it times negative 1, and we get negative 6. That one simplifies to a real number. Okay? Part C. We have negative 5 times 2I squared. Okay? Order of operations in this case says that we need to do the exponent first before we multiply. So we need to square that 2I. That means to multiply 2I times 2I. So 2I times 2I, the 2 times 2 is 4, and the I times I is I squared. Okay? Then we can multiply that by 5, which gets us 20I squared. Our definition says that I squared is equal to negative 1. And then 20 times negative 1 is negative 20. Okay. So for part D, we're going to simplify the square root of negative 25. We're going to rewrite it as the square root of negative 1 times the square root of 25. The square root of 25 should be easy for you. It's just 5. And then the square root of negative 1 is I. Okay? All right. Turn over to the top of page 27. We already did. Page 28. All right. At the top of page 28, we have question number 127. It says, graph the function f of x equals x squared minus 4x plus 5 on your calculator. Okay?